looks great.
Okay, good. So yeah, yes. So good morning. I will share some of our views regarding SMRs, and first here's the outline of my presentation. So I would first say a few words about Fortum and the role of nuclear power within Fortum, and also kind of a summary of all the activities we have been doing on SMRs in the recent years. I will also discuss a bit about the rationale for growth in nuclear power as we see it, or maybe at least as I see it, and I would discuss, let's say, the future technology options, our views on that for nuclear growth, and then I would touch upon a few or discuss some selected preconditions that we think are important to make SMR deployment realistic and possible, and for example, managing licensing risk and standardization and so on. First, this slide is just to highlight the importance of nuclear power to Fortum. So in 2019, nuclear power was, about of all the power generation in Fortum. So nuclear power made up roughly 1/3 of the overall production. And if you look at that in terms of what we do in Nordic countries and within European Union, so you could actually say that in 2019, so basically 1/2 of Fortum's power generation was nuclear. The other half, or a bit less than that, was hydro, and this is because the natural gas section, as is shown in the right hand side of this chart. So this is basically our Russian side natural gas production. As you may know, so Fortum acquired the majority of Uniper recently, and now if you look at the Fortum and Uniper combined power generation at the same time, so even in that perspective, so the significance of nuclear power is remarkable. So nuclear power makes roughly 1/5 of all the power generation of Fortum and the Uniper combined. And Fortum published its new strategy in the beginning of December, and nuclear very clearly is in the core of also in Fortum's new strategy. And then furthermore, in order to highlight the importance of nuclear power to Fortum, so just to summarize our let's say nuclear assets and our nuclear ownership. So as the slide indicates, so Fortum or Uniper is one way or another involved in actually all Nordic nuclear power plants. So in addition to Loviisa, which is of course our fully owned nuclear power plants, so Fortum is a minority owner in Oskarshamn, in Olkiluoto, and Forsmark, and as you know, Fortum is also involved as an owner and also as and has also been providing technical support for two new build projects, which are Olkiluoto 3 and Hanhikivi. So these two projects, obviously, they are at very different stages of development. So, but obviously we have seen much of the challenges related to, let's say, current new build projects. So and also one could note that actually about 65% of Fortum's nuclear capacity is related to co-owned units, so in addition to Loviisa, and this is excluding the Uniper share, and which is shown on the right hand side column. Then I would just try to summarize the activities that we have been doing regarding SMRs. So at Fortum, so SMRs have been recognized as a potential future technology for quite a while, for quite some years, and for several years we have had significant R&D program related to SMRs, and we have been actively monitoring the development of SMR technology, and we have been cooperating with several SMR technology developers and technology vendors, and we have been participating in various international programs. And some of the maybe top areas which I could highlight from our R&D include that we have been looking at possible licensing issues, of course, mainly from let's say Finnish European perspective, and safety design issues. We have been studying certain, let's say, SMR typical thermal hydraulic mechanism or features using our APROS simulation tool. And one particular area that we have been studying is related to as has been mentioned here earlier, is related to the district heat production, either as combined heat and power or as district heating, and we have been looking at those things. I mean, both. I mean, studies on both, let's say, the economic side of that one, and but also the technology side on let's say coupling of a nuclear power plant into a district heating system, and as some of you may remember, so this let's say the nuclear district heating was something that we worked quite a bit already about 10 years ago when we were proposing this kind of option for a possible Loviisa 3 new built reactor, and so this theme is rather familiar to us. Also, I mean, what is highly important, and what we feel is highly important for SMRs to be reality. So is definitely the harmonization of let's say safety requirements and technical requirements in general, and for that, in that respect, so one forum that I would like to mention here is that Fortum has been actively participating also in the European Utility Requirements SMR working group. So EUR is an organization that is formed by major European nuclear power plant operators, and it kind of the main task has been to develop kind of harmonized European technical requirements for nuclear power plants or new nuclear power plants considered for Europe, and of course so far the focus has definitely been on the large nuclear power plant side, but now EUR has also enlarged its scope to the SMR world, and is evaluating what kind of changes and what kind of specificities there are related to SMRs, because it is clearly recognized that for SMRs, so let's say the standardization and harmonization of international at an international level is, if possible, even more important than for large reactors. So this is definitely an important area, and this last but definitely not least, so we have been recently cooperated with Fermi Energia, and we had worked with them on licensing issues, for example, and we also have a letter of intent for a longer term cooperation. This was actually as was already mentioned yesterday by Torbjörn Wahlborg. So with Fortum, Vattenfall, and Tractable are helping or supporting Fermi Energia in their effort, and also from our point of view. So this Fermi project is of high interest, and it's definitely a good possibility for us to how to say, maybe to deepen the understanding of issues that really need to be solved for actual commercial deployment of SMRs. And also then we have cooperation with or have been supported Synthos Green Energy in Poland, who have been also taking the first steps in studying possible deployment of SMRs in Poland and maybe elsewhere. Then a few words, about the rationale of SMR. So why to consider SMRs, as we all know that, for example, last year the power prices in, for example, Nord Pool area were extremely low, and so I mean, how to make the economic sense out of it. So, but we see that let's say but it's clearly seen that the large part of the current power generation capacity in Europe, so that will be phased out in the coming decades in order to reach the aggressive decarbonization targets that we are all aware of. And at the same time, it is clearly seen that the demand for electricity is significantly increasing. So at the same time, there is, a large part of the current capacity will be phased out, and the demand of electricity will increase significantly. And according to there are several studies according to which, so maintaining, if we can maintain nuclear power in the energy mix, so that will bring significant savings in the cost of deep decarbonization of the electricity production. And so clearly we see that commercial-based investments in new build nuclear today may not seem realistic, but due to the aggressive decarbonization targets, so it is seen that the demand for, let's say, dispatchable and reliable carbon-free generation, in addition to renewables, is definitely there, and in particular as the, let's say, the degree of decarbonization increases, and the higher the degree of decarbonization of the whole system, so the more, I mean, the more sense nuclear power makes in the power mix. And we believe that nuclear power may become one of the key technologies also, and including SMRs also in the future. So and in addition to, let's say normal baseload power operations, so of course the SMRs, I mean, are expected, or they need to have capabilities for flexible operation, load following capabilities, and then possibly also, as has been discussed in many presentations during these 2 days, so the capabilities for cogeneration or even for heat only production. But of course, then SMRs, they need to be economically viable. So considering technology, considering project implementation and project risks and financing. I mean, I would kind of like to see. I mean, when discussing about future nuclear technology options, so we maybe see like four different segments from technology point of view. So first of all, of course, there are the large light water reactors of the current, let's say, generation 3, generation 3+. Well, as we all know, so the track record for recent new build projects, in particular in Europe, so it may not be exactly encouraging. However, maybe the situation is improving through the experience and lessons learned from the current ongoing project. So it is not. I mean, we can see that there is improvement in sight also in that perspective. But of course, the challenges are big. Then talking about the light water, let's say small modular reactors, SMRs for power productions, or even for CHP. So the big question is, of course, is that the losses in the economy of scale, so they need to be compensated by other means such as simplification and maximize standardization and so on, as was discussed actually quite well yesterday, for example, in the presentation by CEA. And the smaller upfront investment may ease funding, but the big question, of course, is how to speed up the start of construction of the FOG unit. I mean the first unit or the pilot unit. So this is something that is definitely needed. But clearly the SMRs have big potential. And then what we have been hearing this morning is the SMRs for heat only production for district heating, and we also see that there is potential in particular in countries where there's developed district heating infrastructure. As we all understand that combustion-based technologies maybe will gradually give away to other technologies, and so the heat-only design, obviously, so that gives possibilities for significant simplification of the technology, so that that might make these even at smaller power levels, so they might make them economically feasible. And maybe of course we expect a near-term deployment of these in China, hopefully, and in Finland, as we know. So VTT and Lappeenranta University are working hard on these issues. And then, of course, I mean, the advanced reactors other than light water technology is also something interesting, and we see there the option for process heat and at high temperatures, but of course the big question is that how to speed up the development and get the pilot project ongoing, and maybe the perspective is a bit more longer term. But clearly, I mean, these four alternatives are something that we are keeping maybe at some level an eye on all of them, but SMRs are definitely maybe one of the most interesting things. So then just a few words about what we see maybe the biggest hurdles or that need to be solved for SMR deployment to be reality. And the first issue I would like to raise up is certainly managing the licensing risks. So it is absolutely necessary to avoid unnecessary country-specific design modifications, or also unnecessary changes in the design processes or documentation, so that we can really achieve true standardization. So definitely the way that let's say the large new build projects have been licensed, I mean during this decade in Europe, so that is not possible for SMRs. So there needs to be true standardization internationally, and this is a big question how to ensure that this can be done. And we need, of course, to ensure stable and predictable licensing requirements. So definitely SMRs cannot be afforded to be redesigned for each country. And the international harmonization is definitely ongoing. And of course, I was very happy to hear, for example, yesterday by Anna Bradford about the work that the SMR's Regulators Forum is doing, and clearly the work is ongoing. But definitely this is not an easy job. But but the harmonization is needed in order to SMRs to become reality. Then so for Fortum, as mentioned, so we have studied together with Fermi Energia so possible licensing model for a newcomer country, well, such as Estonia. But actually we found that many of the issues that we identified there are definitely valid also, not only for newcomers, but also for let's say for experienced nuclear power countries. And so definitely, so let's say the ideal way to have would of course to have an international or European design certification for certain types of reactors, but I guess this is something that cannot be realistically expected to happen soon. But what we see is that it is important to pursue the goal that the safety case, let's say a PSAR or so for a next, I mean not for the next unit. So even if it's not, even if this would be first in a country, but not a folk unit. So this should be able to utilize the maximum extent the safety case of the standard design or of the reference plant. At the same time, of course, we need to remember that the licensee is always the one that is ultimately, or he or she is ultimately responsible for the safety. So definitely the licensee needs always to demonstrate the intelligent customer capability and carry out its own safety assessment. And at the same time, of course, the safety authority, the regulator needs each country, so they must have the capabilities and they must carry out its own safety assessment. But it's really important that this safety assessment could be carried out with the maximum utilization of earlier safety assessments in other countries. for example, from the country of origin or wherever the first units have been licensed. and we believe that would be important to try to avoid detailed and too prescriptive country-specific requirements, just to allow to utilize better the earlier licensing processes and earlier safety assessment of a country. And of course, what is important is deep cooperation between the two safety authorities, and there need to be kind of a transparent access to earlier safety assessment and analysis, which would need to be agreed between the two countries. And in order to achieve this, so certainly a graded approach is needed, so that which would need to prioritize the deviations from the standard design or from the earlier licensing and the most safety significant items. And the key thing is to enhance the predictability of the construction license process. And then just shortly, some other further considerations for making SMRs affordable. So I just simply, of course, what has been discussed in many of the presentations yesterday and today. So obviously the simplification, standardization, serial production. So they are crucial for SMRs, and the smaller power of the SMRs obviously they allow to increase the use of passive safety systems and thereby significantly simplify the design. But then, of course, what I would maybe like to highlight is also the increased use of automated controls should allow an optimization of also the operating staff and operating costs, and their consideration of human factors during the design phase is something that I would like to, what I would feel is very important to take into account already in the design. As for supply chain is something that would need to be considered already early on in the project, and as we know, so the use of high quality industrial grade items is something that has been on the table or discussed a lot, and work has been done on that in Europe recently. In Finland, we have the so-called Kelpo project. I know in Sweden there are similar kind of considerations, and also Foratom has worked on this one. But I believe that due to the smaller size, so SMRs may have the potential to benefit maybe even more from utilizing components from already proven that are already proven in other industries, so than maybe the large reactors. So definitely this aspect is something to be considered. And then finally, just to remind that of course it's important to take the lessons learned also from, for SMRs from the current generation 3 Foge project. So even if the track record of the new build project has not been very good, but certainly there are a lot of lessons to be taken, and there's for example the recent OECD report on the possible cost reductions in nuclear. So that's a very good summary of things that can be lessons that can be taken, and the possibilities to decrease costs. And what was found there, that most of the cost escalations in the recent projects, so they are due to indirect costs rather than actual components and materials. So maybe this could be considered also as a positive feature, so that it means that the nuclear projects are not always doomed to be too expensive. So it is possible to tackle the issues and improve the situation. And finally, my last final slide. So we believe that there is potential to make the SMRs affordable and a real contributor to decarbonization in the future. And what is important is that we can to aim at the standard designs with minimum country-specific tailoring, and this means harmonized and stable regulatory requirements and other requirements, and international cooperation in licensing between the regulators and I guess between licensees as well. And also take the lessons learned from the current new build projects to minimize the escalation of indirect costs. So this concludes my presentation. Thank you